Download this code from codegive.com, link in the description below. Rescuing a broken old legacy unit test suite, a comprehensive tutorial. Dealing with a legacy unit test suite can be a daunting task. These tests often suffer from various issues: fragility, lack of maintainability, poor structure, outdated technology, and insufficient documentation. This tutorial provides a step-by-step guide to tackling such a situation, combining practical strategies with illustrative code examples. We'll focus on identifying problems, prioritizing fixes, and gradually improving the test suite's health. Phase 1: Assessment and Prioritization. Before diving into code changes, a thorough assessment is crucial. This involves 1. Identifying the technology stack *, determine the testing framework, junit, nunit, pytest, etc., assertion library, mocking framework, and build system used. Understanding the tools is the first step towards effective remediation. 2. Running the tests *, execute the entire test suite. Note the number of tests, failures, and errors. This initial run provides a baseline. 3. Analyzing test failures *, carefully examine each failure. Categorize them into *true failures *, actual bugs in the code under test. *false positives * tests failing due to test code issues, example incorrect assertions, outdated mocks. *flaky tests * tests that intermittently pass or fail without code changes. *undetectable failures * tests that always pass but don't adequately cover crucial aspects of the code. 4. Code review, selective randomly select a subset of tests and examine their implementation. Look for *test clarity * are the tests easily understandable? Do their names accurately reflect their purpose? *test coverage * do they cover essential code paths and edge cases? *maintainability * is the code well structured, easy to modify, and free of duplicated logic? *dependencies * are there excessive dependencies on external resources, databases, files, networks? *testability * is the code designed in a way that facilitates testing, example loose coupling, dependency injection? 5. Prioritization * based on the analysis, prioritize the tests for remediation. Focus on *true failures * address genuine bugs first. *high impact flaky tests * flaky tests disrupt the CI/CD pipeline. Fix these early. Tests covering critical functionality * prioritize tests related to core business logic. Phase 2: Remediation strategies. The following strategies address common legacy test suite problems. 1. Addressing true failures *. Debug the code under test to fix the actual bugs causing test failures. Use debugging tools effectively. Ensure that fixes are accompanied by updated test cases to prevent regressions. 2. Fixing false positives *. Incorrect assertions * correct the assertion logic in the test to accurately reflect the expected behavior. Outdated mocks * update mock dependencies to reflect current behavior. Unrealistic test data * review and update test data to match the current requirements. 3. Resolving flaky tests * Race conditions * identify and fix concurrency issues that might cause intermittent failures. External dependencies * minimize dependencies on external systems, databases, networks, by using mocks or test doubles. Test timing issues * ensure adequate time for asynchronous operations to complete before making assertions. Environment-specific issues * ensure test environments, OS, libraries, etc., are consistent and well defined. 4. Improving test coverage *. Identify missing test cases by conducting code reviews and using code coverage tools. Add new tests to cover uncovered code paths, edge cases, and boundary conditions. 5. Refactoring tests *. Reduce duplication *. Refactor common test logic into helper functions or classes. Improve readability *. Use descriptive variable and function names, add comments to explain complex logic. Enforce consistent style *. Follow coding style guidelines consistently to improve maintainability. Phase 3, Continuous improvement. After the initial remediation phase, implement the following for long-term maintainability. Introduce CI/CD*. Automate test execution as part of your build pipeline. Code coverage analysis. Regularly track test coverage to ensure adequate testing of the code base. Test-driven development, TDD for new features and bug fixes. Adopt TDD to improve code quality and prevent regressions. Refactoring and modernization. Gradually upgrade to more modern testing frameworks and libraries. Documentation. Improve test documentation to explain test purpose, logic, and expected behavior. Conclusion. Reviving a broken legacy unit test suite requires a structured approach. By prioritizing tasks, applying appropriate remediation strategies, and implementing continuous improvement measures, you can transform a problematic test suite into a valuable asset for ensuring the quality and stability of your software. Remember that this is an iterative process. Continuous improvement is key to maintaining a healthy test suite in the long term.